Let's talk about conjunction introduction and conjunction elimination. Conjunction introduction is a very simple rule of inference. The basic idea motivating conjunction introduction is the following. If you have shown that A, and you have also shown that B, you can infer A and B. So for example, if you know that Anna is at the party, and you also know that Bill is at the party, you can infer that Anna and Bill are at the party. Formally, conjunction introduction looks like this. If at some line in your proof, you have a sentence of the form A, and if in a different line of your proof, you have a sentence of the form B, then you are licensed to infer a conjunction where the first conjunct is a sentence of the form A and the second conjunct is a sentence of the form B. And you can justify this inference by citing the inference rule conjunction introduction applied to lines M and N in this case, the two lines to which you have applied it. So here are various examples of correct applications of the rule conjunction introduction. As we have seen, if in one line of your proof you have the sentence A, and in a different line of your proof you have the sentence B, you can infer A and B. Similarly, if in one line of your proof you have the sentence if A then B, and in a different line of your proof you have the sentence C, you can infer the conjunction if A then B and C, and justify this inference using the rule conjunction introduction applied to lines M and N. Now, the order of the two conjuncts here doesn't really matter. So in the previous example, we saw that if in line M you have the conditional if A then B, and in line N you have the sentence C, then you can infer the conjunction if A then B and C. Now, you can also reverse the order of the sentence C and the conditional if A then B and still apply the rule conjunction introduction. So for example, if in line M of your proof you have the sentence C, and in a later line of your proof you have the sentence if A then B, you can still infer the conjunction if A then B and C and justify this inference using the rule conjunction introduction. To give you a final example, suppose that in line M of your proof you have the conjunction A or B and C, and in a later line of your proof you have the biconditional B if and only if C, then you can infer the long conjunction A or B and C and B if and only if C. And as before, justify this inference using the rule conjunction introduction. Conjunction elimination is a similarly simple and easy rule of inference. The basic idea motivating conjunction elimination is this. If you have shown that A and B, you can infer A and you can infer B. So you can infer either one of the two conjuncts. So for example, if you know that Anna and Bill are at the party, you can infer that Anna is at the party. And you can also infer that Bill is at the party. Formally, the rule looks like this. Suppose that in line M of your proof, you have a conjunction of the form A and B, where the first conjunct is a sentence of the form A and the second conjunct is a sentence of the form B. The rule conjunction elimination then licenses you to infer the first conjunct A, as long as you justify this inference by citing the rule and the line to which you apply it. The rule also licenses you to infer the second conjunct B. So suppose that just as before, we have the conjunction A and B in line M of our proof. We can then infer the second conjunct B and justify this inference citing conjunction elimination. So here are a few applications of the rule conjunction elimination. The first two examples we have already encountered. If in line M of your proof you have the conjunction A and B, you can infer the first conjunct A, citing the rule conjunction elimination as applied to line M. And similarly, if in line M of your proof you have the conjunction A and B, you can also infer the second conjunct B, and again cite the rule conjunction elimination to justify this inference. Now, the same works even if you have more complex conjunctions. So, for example, if in line M of your proof you have the conjunction if A then B and C, you can infer the first conjunct if A then B and justify this inference by citing conjunction elimination applied to line M. Or, to give you another example, if in line M of your proof you have the conjunction A or C and B, then you can infer the first conjunct A or C and justify this inference by citing conjunction elimination. You can, of course, also infer the second conjunct B, as discussed in the next example. So if in line M you have the conjunction A or C and B, you can likewise infer the second conjunct B and cite conjunction elimination to justify this inference. Now, to look at the final example, if in line M of your proof you have the conjunction A and B if and only if C, you can infer the biconditional B if and only if C, in this case our second conjunct, and justify this inference by citing the rule conjunction elimination applied to line M.